Welcome to this advanced tutorial titled IQ Constellation versus Frequency. In this tutorial, we will continue with mqam as our focal modulation scheme. First, we will expand our IQ constellation discussion to include 4 qam all the way up to 256 qam. Second, we will also look at the baseband fast Fourier transform, or spectrum, with a root-raised cosine filter applied to each of these modulation schemes. Third, having looked at quadrature skew and IQ gain imbalance in an earlier lesson, we will revisit them in this lesson and take a look at what effect these impairments have on the higher order mqam schemes and see what conclusions we can infer. This tutorial utilizes the Baseband Developers Kit, so if you wish to follow along, click on the Modeling Baseband Impairments under the Advanced Teaching Examples. First, let's review 4 qam. Recall that it has 4 symbols where the I and the Q state can be either 0.707 or minus 0.707. Now let's take a look at 8 qam. We can adjust the modulation type from 4 qam to 8 qam in the lower left-hand corner. Notice that in 8 qam, the maximum and minimum voltages are still plus and minus 0.707. In fact, the outer edges of the square are the same as 4 qam. 8 qam adds 4 new additional symbols. They are located at I equal to 0 and Q equal to plus or minus 0.707, and Q equal to 0 and I equal to plus or minus 0.707. This suggests that the other 4 symbols are obtained by setting the I or the Q signal simply to 0. If we look on the IQ data tab, we get the baseband waveform in the time domain, and we can see the I and the Q waveform occasionally transmitting at 0. In order to realize 16 qam, we have to actually add a new voltage level for I and Q of approximately 0.25 volts. So you can see we've had to significantly reduce the distance between symbols. For 4 qam, the minimum distance was 1.4 volts, whereas for 16 qam, the minimum distance between symbols is only about 0.45 volts. This is a factor of 3 times shorter. 2 to the 5th would be our next qam state, which is 32 qam. The best shape that optimizes the distance between symbols is a square with the 4 corners missing, shown here, meaning they're not used. Not using the 4 endpoints is the best option because those 4 points would require the most transmit power and would be the most susceptible to noise, imbalances, and other impairments. The constellation for 2 to the 6th, or 6